Alright, so here's the code walkthrough for the 4th Baking Pi tutorial from Cambridge University. I'm going to start off with the main file. Not too much has changed here since the last one, save for these two lines right here. These are what cause the delay. Instead of doing how we did previously, which is just decrementing a large number down to 0, it's kind of imprecise and depends on what kind of hardware you're running on. But we implemented it this way, which will actually just call out to the system timer, so we can specify how many seconds or how many microseconds is actually what it's in. We want a delay. Here I have it set to 9 million microseconds, or 9 seconds. Kind of high. It was originally set to 1 million, so it would flash on and off with 1 second. The LED will then turn off, and we run the code again to cause another delay before it turns back on. So I'm going to open up the other file, the system timer file, and we can go through these functions just step by step. I kind of already included a little bit of description as to what each of these does in the actual blog file, but I'll go through them here as well. So our first one, we have the get timer address. It's the exact same thing as the get GPIO address. It's just the actual address of the timer in the hardware, which is this right here, and that's what we're going to set R0 to. That's the only functional line in this, and then we're just going to hop straight back to where we were before. That's all that line does. So after that, we have the get to current time function. All it does is load the current time into a register, where actually it has to be 2 registers because the counter is stored in 8 bytes, whereas the registers are only 32 bits, or 4. So we have to store it across 2, which is what this function does. It'll put the value in R0 and R1, so we have the entire timer value, and then we're just gonna pop. Sorry. We had put the link register, push it on top of the stack, and then call our get timer address, and so after that we'll just we'll pop back off of it to get back to where we were before. The next function is definitely the most important, probably a little bit more complicated than the others, but it's really not too difficult. All this is going to do right here is just call out to our get current time. So now we know before we enter the loop what the time is right now as we start the delay, and this is what's going to be running the majority of the time. We're just going the gist of it is pretty much we're going to keep checking and see if our elapsed time is equal to what it should be, which is what we passed in for R0. Once our elapsed time is equal to that, we're just going to pop out of the loop, and we'll just keep doing that by calling get current time check every single time we go through the loop. And as soon as they're equal, then we're just gonna these again, just getting rid of the aliases, they're not important. And again, we push the link register onto the stack, so we're just gonna pop it off, and that'll return back to wherever we were before, which will just be here. And then this process will just loop forever, turning the LED on and off, and you can see that the actual compiling and running of the code in the other video. So thank you for watching.